for our last speaker of the day, I want to introduce to you Kirstie Whitaker, who is a research fellow at the Alan Turing Institute in London and a senior research associate in the Department of Psychiatry at the University of Cambridge. She is a huge fan of open science, and she will introduce you to the Turing Way, which is about reproducible science.
That's right. Thank you so much. It's truly one of my most nervous aspects of public speaking is that I'm going to go last, and I always feel so worried that all the previous speakers are going to have included absolutely everything that I want to say. And that's sort of true, but I pivoted my slides halfway through today, and I'm going to sort of unfortunately use that against you and tell you all that you should all contribute. Ha-ha! To the Turing Way, please. The Turing Way, this is not my pointer. No. Yes. There you go. I think I just used the... Do I have a pointer? Oh, it's here. Thank you. Here I go. So the Turing Way, I like to put my acknowledgement slide at the beginning because I sort of always feel like the questions, the conversations are most sort of interesting to me, and I don't really want to kind of undermine the acknowledgements and thank you for my amazing team by trying to rush towards hearing from you. So the Turing Way it's a book. It's a Jupyter book, so thinking about the future of publishing. It's literally published online, straight from GitHub, from your Jupyter notebooks or Markdown documents, boom, straight away, no problem. It's also a community. I'm obviously going to tell you a little bit more about both of those things. It's a global collaboration, and it is such a lot of work. And it's really, this has come up a few times today about sort of building spaces where people can share all of this information, especially as we start to generate more and more information, is a lot of work. So I want to particularly thank Rachel, Becky, Louise, Sarah, Patricia, James, Rosie, Anna, Catherine, Alex, Martin, and Malvika. Malvika is going to be giving a talk in the train track on the Thursday of this session. And I also want to thank all of our contributors. We're going to come back to this slide in just a little bit, but we have about 70 different contributors, and we want to try and have more and more as we go along. So let me just take a step back and tell you a little bit about who I am. I really like fancy coffees, that's why that's there. And this was a picture that was taken of me using Docker on my Windows laptop for the first time, which if you've ever tried to use Docker on a Windows laptop, that's why I am so delighted that it's actually working. I share a lot of sort of the experiences that the speakers have shared all through today. I've definitely p-hacked, I've definitely harked, I've definitely got a lot of work that didn't tell the interesting story that we were looking for. So almost everything that I've ever done is in a file drawer, the metaphorical file drawer somewhere, and that's kind of one of my big motivations for trying to change the way in which we share and sort of build scientific knowledge. I now work at the Alan Turing Institute, where I focus on trying to use the UK's National Institute to incentivise and change the system to reward the people who are building open source projects to help each other out. So just as a couple of background slides about the Turing Institute, this is not, in fact, Alan Turing, but this is Alan Turing. He was nominated in the UK as the person of the last century, person of the 20th century. And it's pretty cool that there was a scientist was the person who won, but it's not that cool that every one of the finalists was men, so we can just pay attention to that for a second. This slide is here just to encourage you that if you ever do come to London, there's only it's about a 45-minute train journey from the centre of London to go to Bletchley Park, which was where Alan Turing, in secret, worked to crack the Enigma code and worked as part of the World War II Allied effort. And it's really fun. I strongly recommend it. It's very nerdy. The Turing Institute is 1/3 funded by government, it's 1/3 funded by our 13 university partners, and it's 1/3 funded by our industry partners and collaborators. And some of our goals are, just to advance data science and artificial intelligence to revolutionize healthcare, or manage security in an insecure world, or supercharge research in the science and humanities, or even, just make algorithmic systems fair, transparent, and ethical. And so we will be done in a few years' time, no problem. I put this slide in here because I know I'm not talking to people who would probably call themselves data scientists. So you may call yourselves physicists, you may call yourself neuroscientists, you may call yourself engineers, brain imagers. My personal definition of data science is that it is the process of applying software, data management, or data analysis practices from one domain to another, including the reuse of data to answer a new research question. So by that definition, many of you will, in fact, I would call you a data scientist. So my definition of data science is that it is innovative, collaborative, and interdisciplinary research. So if you stay inside of MR physics, for example, or inside of brain imaging, and you never sort of learn from other areas and you never try and work across domains, you're probably not a data scientist, even though you're a scientist who works with data. But if you try and bring sort of insights from other areas into the research questions that you want to answer, then I think you are. And most importantly, this Venn diagram has a unicorn at the center of it, and I don't think we should be breeding unicorns. I think they're very rare, they're very difficult to find. I think that we should be delivering data science as a team of experts, and we don't need to try and have all individually be amazing at absolutely everything. We're going to work together to answer the really important questions. So this is where the Turing Way comes in. So the Turing Way, this is a screenshot from the online site. The URL is down at the bottom. And, I forgot to say that the DOI down at the bottom links to the slides. They're CC by. You're very welcome to use any of the content there for any purposes. It is the Turing Way is a lightly opinioned guide to reproducible data science. If you've met me, that lightly opinionated is somewhat hilarious, but we're going to try for lightly opinionated. And our goal is to make sure that PhD students, postdocs, PIs, and funding teams know which part of the responsibility of reproducibility they can affect and what they should do to nudge data science to being more efficient, effective, and understandable. Now, this is, if we sort of dig into what does reproducible even mean, we've had all of the different facets all of today. You're going to work over, there's the train track for the next 2 days. You're going to work in groups on really amazing projects to try and improve this aspect of collaboration, openness, reproducibility. But actually, we have to cover all these different areas. So it's a cycle, right? We can start with data collection. Well, there's things we could do to do better at data collection. There's things we could do to be better at data processing, data study and analysis, data publishing and data access, or access to the insights, preservation, long-term preservation, 50 years, 100 years, 3,000 years. That's too many. Data reuse, what does that look like? Generating new research ideas. You can use natural language processing to try and mine the literature to come up with new insights, and then getting back into your planning and design and going round and round in the cycle. And if you start to try and think about all of the different steps to revolutionize those, it's an awful lot, and I don't think that any one person should have to do it. And so that's the point of the project, is to try and help along the way. So some of the chapters that we already have is we have some definitions. So I personally define computationally reproducible as me having a set of data and a set of steps that I have followed to do something to that data. And if I give you both of those two things and the computational environment that I used as well, you can get the exact same data. That's what I mean by reproducible. You can mean whatever you want, but we should be able to kind of share the concept together. Replicable would be if I share my code and my computational environment maybe, and then you run it on your own data sets. That's a really nice way of trying to get the same results qualitatively, but not quantitatively. I'm very, very interested, and I think there'll be probably quite a few people here interested in this cell around the robustness of the results. So people usually compete methods against each other to see which one is better. And actually, as Cass said in her talk, maybe there isn't, unfortunately, an answer to which one is better, especially if you're looking at something as complex as the human mind. And so maybe just knowing that you get qualitatively the same result from all of these different methods is enough. Maybe just saying like, okay, it's pretty okay. We're not too close to a boundary there. We can be confident about it. And then I just want to emphasize that the last cell says generalizable. It doesn't say generalized. So it is, I think, it is a sort of necessary but not sufficient step that you should be able to have somebody else get the exact same values as you for that paper that you've published, those effect sizes, those results. Somebody else should be able to check that. I feel like we've got into a space where that's not required in the 21st century. That seems very strange. And I also think we should get to a point where you can find it in just one other data set. And if somebody wrote the code in R versus MATLAB versus Python, but qualitatively should be doing the same thing, I feel like those are necessary but not sufficient steps to being able to really stand on the shoulders of the work that's come before. We also have a chapter on research data management. So we talk about the FAIR principles, which are findable, making data, but it's being extended into software. Findable, accessible, interoperable, and reusable. And I'm very passionate about things like synthetic data and synthesized data, and also safe haven working so that you don't have to make everything totally public. It would be irresponsible to make everything totally public. And so finding ways to build these interoperable systems that are open source, documented, but still maintain the privacy of the patient data that's inside of it. We have a very, very cool chapter on testing. Can you wave at me if you implement tests for your analysis code? This is pretty good. It's pretty good. Yeah, it's all right. It's pretty fun. So I'm like super, super into testing. Specifically, I'm very interested in the language that is used in Python, and I think it's similar in R as well, where it's really semantic. Like, literally, if we say, we have a function that says get the time of day, so this, because the sun is up, it's morning. Get the time of day, compare it to the string morning, and if they are equal, assert that they are equal. I state into the world that it must be true that these are equal, and if that's true, and if it's not, then your tests will fail. And I think it's a really simple line. We've very rarely taught it. It's very, very cool. And Louise, who is a member of the team, she's a data scientist at the Turing. That's a job title as well as like a concept. Recommends that you add a test before you change anything, particularly if you're just going to tidy up your code before sharing it. We have received lots of code that is much nicer, it's cleaner, it doesn't have lots of commented out sections that aren't used anymore, but it no longer actually gives you the same results as in the published paper. So this is your moment. This is your moment. Either don't clean up your code, just be super proud that you're sharing it, that you wrote code in the first place. Thank you. Much better to receive code that actually gives you the result than code that gives you like either a new or maybe a better result, but better is this slippery concept. We're also really interested in continuous analysis. So continuous analysis is inspired from this software industry engineering concept of continuous integration, which I think was mentioned in the industry talk. There's just after lunch. I think it's very cool because it maps really nicely onto the concept of how science should be done. It's not the way that science is actually currently done, but how science should be done. That you might plan and design. I'm going to turn around. Plan and design, code and build your design, push it to version control everything, run those analyses, and then see what's changed. And you might then go around another cycle because you might have like missed something and you've got outliers in there, you've got weird values or things like that. But you keep running all of your analyses all the way around. Importantly, I've got this short bullet point here that it's traditionally done in the cloud. That's only if you have data that can go into the cloud. And maybe that's test data, maybe that's synthetic data, but you can actually run continuous analysis anywhere that you are. You can do that on secure data as well. And Becky, I'm going to take a moment here just to explain why Becky is this green monster. She is a postdoctoral researcher who worked on the project. She wrote a huge amount of the content last year. She doesn't like having her photograph up everywhere on the internet, and as I told you, my slides are publicly available and you can reuse them. But by chance, if you Zoom using the remote connection video conferencing software, from a Linux machine, or at least specifically her Linux machine, this is what she looks like. So this is the picture that I use. We've had a bunch of calls with her, joining us and discussing with the team. And one of her big sort of breakthroughs, one of her big insights was just how many things you need to know in order to do continuous integration. And I think not we in this room, but we as a community aren't very good at sort of recognizing how much expertise we have once we have it. And so finding ways to make that really pedagogically accessible is important. So let me just tell you for a second now about version control. Can you wave at me if you use Git for version control? Okay, this is very cool. You got a whole bunch of stuff. Can you wave at me if you have opened a pull request? It's very cool. I'm liking it. Slightly fewer hands than last time. Can you raise your hands if you have received a pull request? So if you've reviewed a pull request. So that's fewer again. And have you received and reviewed a pull request from somebody that you don't know, that you've never met? So there's very many fewer than that, okay? And my point with this is that there are lots and lots of steps along this journey, but, and I want to sort of emphasize, I won't go into a massive amount of detail because you probably already know it, that Git is the software that does version control, and GitHub is this sort of social coding platform, is this like social media sort of inspired conversational place where you can talk and collaborate and work with each other. The picture on the right is Dan at NeuroHackademy, and I was sort of explaining how you could make changes on your local machine, you could push it up to the origin, which is your fork of a repository, and then how you could go about doing a pull request. It always takes quite a long time for people to really get that, so if you don't know that, please do go to the session. I think there's one tomorrow, and sit with someone and have them help you. And if you don't know, if you know how to do this and you talk to anyone who's not sure, please help them. It's really hard to get all of this jargon down, but it's unbelievably empowering once you have. So I just always really loved Dan's like gigantic grin once he like had figured it all out. And I've kept this slide in here, that every hackathon should have a gong that you can ring when you complete your first pull request. Like, that's how hard it is to complete your first pull request. And I can't remember who said it at NeuroHackademy a couple of years ago, so I'm crediting all of the amazing participants of NeuroHackademy. Applications for NeuroHackademy are currently open. It is a 2-week-long, it's like a 2-week-long version of these 3 days, essentially. You have 1 week of talks and workshops and code-along experiences, and then the second week you work in groups and you work towards projects. It's bringing sort of data science, open science into neuroscience, brain imaging mostly. So everyone here is very eligible to go. You should apply. I want to have a little note on the name of the Turing Way. So I did not think that this was going to fly when I made it up. And it's actually, it causes some sort of, I think, misconceptions. So importantly, the Turing Way is not a Turing Institute project, and the way is not a set of rules telling you how to do it. So it's funded by the Turing Institute. It's funded by a grant that came in from the UK government to innovate the UK economy for around data science. But it is a project it's a community-driven open source project. If I stopped existing, the Turing Way, because it's new, would probably sort of lose quite a lot of its momentum. But my goal for 2020 is for every one of these talks that I give about the Turing Way, I want by the end there to be 2 talks given by other members of the community promoting what we want to do. We have a code of conduct that specifically has a way of reporting challenges where I have been problematic. So we have someone who's outside of my reporting line at work to be able to kind of feed that on. And I think it is a huge goal that we are sort of trying to build together an open source project that is bigger than any one individual, even a team of individuals. And there are no rules. Like, no one knows how to collaborate. No one knows how to do reproducible data science. Nobody knows how to revolutionize scholarly publishing, but we can figure it out together. So it's a path. It's not a set of rules. And we're going to expand. And this is this meme that our artist drew of me, which I do say in basically every conversation, that pretty much anything that is not domain specific could be a chapter in the Turing Way. So we're going to expand from reproducibility to include scoping and designing a data science project. How do you think about designing a project? How do you make sure that you're going to be able to get access to the data? How long is that going to take? How are you going to make sure that you've pre-registered your hypotheses and you're confident in your statistics? I'm the chair of the ethics advisory group at the Turing, so we're going to make sure that you're not doing social harm as a result of the work that you're proposing, mining facial recognition data, for example. We want as many things in there to help people to communicate their work really broadly. There's a chapter already I have to review, actually. If anyone wants to review it, that'd be great, on outreach, so how to do science outreach. But including things like how to make really beautiful figures, like, I don't know, ones that sort of sparkle and chatter, or particle physics and things like that. And how you can kind of share the work that you've done in a really accessible way. And then my great passion is around collaborative working. How do you run inclusive spaces? How do you chair a meeting? How do you organize people who are geographically distant? These are some ideas that I put in here from listening to the talks and from some of the hackathon projects. So I think this is a spectacularly well-run event, and I would love for the organisers to have captured a lot of the things that they've done so that others can learn from that as well. We've got a few different open standards were mentioned. I'm most involved in the brain imaging data structure, so the BIDS project. Documentation around that, helping people get involved in building standards and building tools that use standards to incentivize standards are really important. How to talk about open source, open access, open science, open scholarship in lots of these different ways. Tips and tricks on how you do that, how you build culture change would be wonderfully welcome. Responsibly managing data in secure environments, for example. I already mentioned the exploding visualizations. And Malvika Sharan, who's the community manager for the Turing Way, she's a postdoc working with me. She will be here on Thursday, and she is just really, really expert and just fantastic educator and supporter of sort of inclusive spaces. So I recommend learning from her. The project is a global collaboration. And Patricia, who was a member of the team, said, as a quote, "What really sets the Turing Way apart is how we're writing the book. The focus on community, the commitment to transparency and working open right from the beginning is an exciting and terrifying new way of working." And it's wildly revolutionary when you really dig into it. I had a fellowship from Mozilla. You know about Mozilla if you've ever used the Firefox browser, but they want to maintain the web as a resource that is open and accessible for everybody, and that includes revolutionizing how we share scientific and academic knowledge. And their 3 open leadership principles are that you make the work accessible and clear, that you make the work easy to adapt, reproduce, and spread. So that involves licensing in the sort of smallest and most narrow way, but also that you use words and you build kind of community in a way that empowers people. And you also build shared ownership and agency to make the work inviting and, importantly, sustainable for all. These are our contributors again. The thing that I love about this slide is that it's literally always out of date. Every single time I give a talk, I know that there's somebody who isn't captured on this version. And what I want to just highlight here very quickly is the emoji key. So just in case it's a little bit difficult to read, I'm going to highlight some of the different ways that people can contribute to an open source project that's run on GitHub. You can get an emoji for event organizing, for reviewing pull requests, for sharing your ideas, that's the thinking emoji, for helping out with the design, for improving the way that it looks. You can get an emoji for project management, for giving a talk, for building a tutorial, for translating it into other languages, for reporting reporting bugs, answering questions. You can give us financial support. You can also find financial support. And then finally, you can also get some emojis for either writing documentation or contributing lines of code, those two things that we've sort of very traditionally looked at to measure contributions to open source projects. We have these events that are called book dashes. A book sprint is usually 3 to 5 days long as a way of working collaboratively together, and this is just a 1 day long event, so it's shorter than a sprint, which is a dash. We had 2 in May 2019. They were absolutely spectacular, and just yesterday I reviewed, and it was very, very difficult to choose 15 people to come to London to contribute in halfway through February of this year. It's a really, really sort of great space, and it's amazing how much knowledge you can get out of yourself and onto a page in just a few hours. We have a chapter on risk management that was written in 3 hours, but it's with a sort of concerted effort put aside for that purpose. We also have collaboration cafes. These are online, so you have to bring your own coffee and slice of cake. They're on the first and third Wednesdays of every month. The first Wednesday of the month, they're at 3 p.m. UK time, which is 4 p.m. In the Central European time. And on the third Wednesday of the month, they're at 7 p.m., which is 8 p.m. here. And that's to try and sort of spread time zones for people who have different and conflicting responsibilities. You join a Zoom call. We have a little chat at the beginning. We say hi to each other. And then we do 3 rounds of Pomodoro sprinting. So these 20 minutes of sort of try and get something done. It's amazing, like I said, how much you can do in just a few bouts of 20 minutes. And then we have 30 minutes at the end of just sort of answering questions, brainstorming, thinking about the progress that we've all made and where the project needs to go. Everybody is welcome, and it's really fun to see people on those calls. Our metrics for success, I want 20 new chapters by the end of 2020. I want 100 authors. We're at sort of 60 or so now, so I think we're doing okay on that front, but 100 authors, 200 contributors. The difference between those two is basically a sustained contribution, so fixing a typo, you're a contributor. Fixing a typo every single month, you're getting over into authorship. Writing a chapter, editing a chapter, moving a lot of content around, you're starting to go into authorship criteria. I'd really like 1,000 mailing list subscribers. So if everybody could just open up tinyletter.com/Turing Way, that'd be great. It's also really helpful for us telling you about opportunities and things like that we have. And then, as I was saying earlier, I'm very, very passionate about supporting people to do their first pull requests. So we want to try and have, ideally, 50 first pull requests into the project, because that's how proactive we want to be about bringing people in and having them share their expertise. And then the last thing I'll say on this slide is that the goal is to build a decentralized, connected system rather than reinvent the wheel all just in one place. So the Turing Way, the content in the Turing Way should ideally signpost out to content that already exists rather than rewrite it. But it's all in one place, so it's a little bit more discoverable and a little bit easier to find. And importantly, if someone comes along to me and says, the documentation for TensorFlow is really terrible, there's a bit missing and you just need to do this, that is not content for the Turing Way, that is content for TensorFlow's documentation. And contributing to large-scale projects, open source projects, is really nerve-wracking, but we want to try and mentor and support those people to put their contributions in. And of course, I would really love for all of you to contribute, please. I'm very near the end. This is, I think, well, I really like the one of me, obviously, but I think this is my favorite cartoon from the book dashes, from the artist who came along to the events in May. He really captured this idea of nurturing the community, of growing all together and welcoming. This is me sort of aggressively welcoming you to the Turing Way garden. And I'll just finish with a quote from Alan Turing, that sometimes it's the people no one can imagine anything of who do the things that no one can imagine. So please come and join us. I want to thank all of our contributors again, and thank you for listening.
Thank you for your very nice talk. Are there any questions?
So that, hello? Yep.
Yeah.
There's an impressive amount of industrial partners supporting the Turing Institute. Are any of them going to pick up the Turing Way?
Yeah, that's the goal. So we have, they are interested in it. And in fact, actually, that's an edit that needs to be made to that introduction page to make it much sort of a little bit less focused on academia. I think a lot of the stuff around how do you design a project and how do you think about the long-term sustainability of a project? How do you test a project? That is actually done much better in industry than in academia. One of the things that, so my partner works in industry, and one of the things that he and I just like, we do not understand about each other's lives is when he finishes a job, he does contract work, he doesn't get fired all the time from permanent jobs, but he finishes work in a few months and then he moves on to another one. And when he leaves, like, he's gone. Like, he has no access, he doesn't get access to his emails, there's no documents that he has written as part of that job. So the documentation of what he was doing has to be 100% because somebody will come into that role and they will need to know what's going on. And so you need to be really replaceable, and that's both documentation, process, and also a lot of the testing. So I think there's a lot of contributions that we can bring. That one on risk management was actually from someone who's a data scientist at the Met Office. And so I think there's lots and lots of scope for trying to bring that in. And I've given a couple of talks at PyData events, which are open source for people who are using Python to work with data. And I've definitely heard from a few of those folks that they're using some of the guidance in the Turing Way, which is really nice. Yeah. Do you have the microphone at the back? Yeah.
It's all right.
Oh, no, can you use the microphone, please?
Oh, yeah, sure. So you're very enthusiastic about pull requests.
Yeah.
I'm wondering who's reviewing these. Is the entire community doing this?
So, yes, that is a really important task that we would love for a few more people to do. Yeah. Do you have like a thought behind that question?
Yes, I was wondering, is there like this one person who is able to say, yes, this is good enough and I don't want this in? Or is this also something that the entire community does, like, sort of together?
So best case scenario, it's the whole community. You'll actually see that Malvika hasn't officially started her job yet. And if you go to the Turing Way GitHub repository, you'll see a lot of stale pull requests because as you may have already predicted, do not scale. And it turns out I don't have enough time to review and read carefully and give feedback on all of the different pull requests. That's why we have to have a full-time community manager, not to just review the pull requests, but to sort of shepherd these along and wake up in the morning and kind of check where we're going. The only thing that would probably be like escalated to me is around this lightly opinionated aspect. So if members of the community who were not, if they weren't sure whether something was opinion or kind of generally accepted, that's probably something that they would be like, Kirstie, can you look at this? And I would almost certainly have input over the structure. But usually the way that it has worked in the past and that I hope it will work going forwards is that I am like a final kind of, yeah, I trust, like I've read the reviews look good, I don't think there's any problems. So it's definitely the case that one of the most valuable things that we can have, one of the most valuable contributions we can have are people reviewing the content. And then this isn't what you asked, but I'm going to answer a different question, which is, the book is a living document. It's always published. It's always online. So that means that as somebody adds a new chapter, it now is slightly out of sync with other chapters that were written in a different context. So I think we define a pull request at the moment in like 3 or 4 different places. And that's, that's the role of, that's why you pay professional editors to like look over things. So I just want to sort of highlight that somebody reading the Turing Way, finding it useful as they're working on an analysis, if they see that there's this duplicate that we've got sort of slightly out of sync with the wording, that is also an extremely valuable contribution, even if that person doesn't go ahead and fix it, just to write an issue to say, I've noticed that these 3 sections use slightly different wording to describe something, maybe it makes sense to harmonize them together. That'd be really valuable. That's an really important aspect. We'd love to recruit people to do.
So what does it look like if you look at those 70 contributors to date? Is it mostly people from like research environments, or is it a lot of people also just like from the public or from companies, or what type of, and do you look for a specific profile? Don't you care?
No, so the way that you would become a contributor is you would open an issue, best case scenario, you would open an issue, somebody would say, yes, that is, you are right, that is a typo, you are right, there is a broken link there. Yes, we would love to have a little bit of a description, linking out to some guidance to kind of the best ways of using color bars, or choosing color for your visualization or something like that. You'd open an issue. We would say, that sounds great. Or we would say, actually, someone's already working on that, so you should link up with it. And then you'd open a pull request, and essentially, once you've touched the pull request in any way, we have this little all contributors bot that will add you as a contributor. Now, one of the things that I would love to hear from people over the drinks, or you can contact me on the Slack, send me direct messages on Slack if you'd like to, is even though it's really easy, very few people do it. So it's amazing that we have these 70 people. But we did also run 2 events where people were specifically selected. We also did a hacker event at the Software Sustainability Institute's collaborations workshop. So we've done quite a lot of those people are quite sort of mentored in to the community. So anyone who has not made a contribution to any open source project, you don't have to have not made a contribution to the Turing Way. I'm really curious to know what the barriers actually are, because there's not many people who are in no way connected to my or the other members of the team's broader network. Usually it's because people know somebody and have sort of been helped into that group. But I do hope that there will be more. The goal, the dream is to have people from industry for sure, people from government and how they're working, and then I think it'd be a really fun place for people who were master's students or first year PhD students as they were learning a topic to contribute into that documentation. I'd love that.
Any more questions? Nope. Okay.
Cool.
Thanks, Kirstie.
Thank you. Thanks.